What's up, fellow Husky calculus students? This is Marco Cordero from Mr. Che's A5 calculus class, and today I'm going to be doing my video project on lessons 5.8, 1.3, and 5.9. And to start this off, I'm going to be reviewing some terms for this lesson. And so the first term that I'm going to be reviewing is discrete variable, and this is a variable which can only take a countable number of values. Next is a continuous variable, and this is a variable where the data can take infinitely many values. The next is probability distribution, and this is a function of a discrete variable whose integral is the probability of a random variable. Next is Pascal's triangle, and this is a triangle that has, as you can see, it has rows on this side, and the first row only consists of 1. The second row has a 1 and a 1. The third row has 1, 2, and 1, and so on, as you can see. And so what's interesting about this triangle is that if you add up the numbers above and make a triangle with it, you can see that they equal the number down here. So that's how you can find all the rest of these numbers. And then another interesting thing is that this row that is diagonal, all of these are constant, and then the row next to it, all of them are linear, and then the row next to it, they increase quadratically, and the next one cubically. And so the next term after that is factorial, and factorial is a product of an integer and all of the positive integers below it. For example, 4 factorial is equal to 4 times 3 times 2 times 1. The next is binomial coefficient, and binomial coefficient is having a set amount of numbers and only choosing a number of them in a certain way, such as n choose r. An example of this would be 12 choose 8. So how many different ways can you choose 8 out of 12 different sets? And so the next one is binomial theorem. I accidentally wrote coefficient, but yeah, binomial theorem. And this is a formula for finding any power of a binomial without multiplying it out, so you don't have to do the whole thing and be redundant. And so next we have binomial experiment, and and this is a statistical experiment that consists of n repeated trials with only 2 outcomes, either success or failure. Binomial probability distribution is the next one, and this is used to obtain one of the 2 outcomes in a certain number of times, represented by k, out of fixed trial n of random event. Okay, so now that we're done with our terms, we're going to move on to a practice problem. And our first practice problem says, find the last 3 coefficients from x plus 8 to the power of 6 expanded. And so first what we're going to do is find out which formula we're going to be using for this. And the formula that we're going to be using is the binomial theorem. And so it's this one. So to write that out, it's like this: parentheses a plus b to the power of n is equal to a to the power of n plus n choose 1 times a to the power of n minus 1 times b plus n choose r times a to the power of n minus 1 times b, and then so on and so on until you just get to b to the power of n. And what I like to do is put a 1 here just because it makes my understanding of it better. So, and then once we know what formula to use, it's important to understand how many terms are going to be in this expanded equation, because if we're going to find the 3 last coefficients, we should find out how many terms there are overall. And so we know that there's always, if it's to the power of 6, there's going to be 7 terms, because that means we're going to have 6, we're going to have something to the power of 6 to the power, an x to the power of 6, an x to the power of 5, x to the power of 4, x to the power of 3, x to the power of 2, and x to the power of 1, which is just x. And then we're also going to have just a constant at the end with no x. And so once we find out how many terms we're gonna have, we have to find the 4th, 5th, and 6th term, because those are going to be the last terms with a coefficient, because the last term is only a constant, it doesn't have a coefficient. And so if we are going to find the coefficients for the 4th, 5th, and 6th term, we have to understand that means r. So to find r, because if you look at this example, this is the first term and this is the second term. And so we can see at the second term that r is equal to 1. So that means by that we can see that your r will always be equal to your term number minus 1. So that means if we were trying to find the 4th term, if we were trying to find the 4th term, that means we would do our number term minus 1, and that is what our r is equal to. So for our 4th term, our r is equal to 3. And so that means for our 5th term, here I'll write right here, 5th term, r is equal to 4. 6th term, r is equal to 5. Okay, and so now that we have our r values, we have to find our n and our a and our b. And so as we can see, this looks pretty similar. So we can just put them above each other, x plus 8 to the power of 6, and then a plus b to the power of n. And so by that we can see that a is equal to x, b is equal to 8, and n is equal to 6. And so with all of this information, we're going to be able to find out our 4th, 5th, and 6th coefficients using this formula right here. Because we don't need this, because we don't need to find the first term. We need to find the 4th, 5th, and 6th term. So we just plug it in. So for our 4th term, our n will be 6. So that means 6, choose 3, because our r is 3 for the 4th term, and then that is times a, which is equal to x to the power of n, which is equal to 6, minus r, which is equal to 3, is equal to 3, times b, which is equal to 8, to the power of r. And so r is 3 for the 4th term. So we put that into our calculator, and the way to put and choose r into the calculator is to go to math, go to probability, do NCR, and so our first number is going to be 6, because 6 is our n, and r is 3, so that gets us 20. So 20 times x to the power of 6, or x to the power of 3, sorry, 6 minus 3 is equal to 3, times 8 to the power of 3, 8 to the power of 3 is equal to 512. So we do 512 times 20, that's equal to 10,240 x to the 3rd. And so 10,240 is our answer to the 4th coefficient, so we need to find the answers to the 5th and 6th coefficient. So to do this, we just repeat what we did, but plugging in a different r value. And so r value for 5th term, n, a, b, and n all stay the same, we just change r. So n is 6, And r now is going to be 4. We found that out from subtracting 1 from our fifth term. So that's 4 x power of 6 minus 4 times 8 to the power of 4. We type all of this into our calculator. Math, NCR, 6, 4, 15 times 6 to the power 2 times 8 to the power 4, which is 4,096 times 15. So we got 61,440 times x squared. And so 61,440 is our answer for the fifth term. And so for the sixth term, all we got to do is change r to 5. And so just set that up like this. Put 6 choose 5 times x power of 6 minus 5 times 8 to the power of 5. Put NCR 6 choose 5. That gets you 6. And then 8 to the power of 5, and that's 32,768 times 6. That gets you 196,608 to the power of x, times x. And so that means our answers are 10,240 for the fourth term, 61,440 for the fifth term, and 196,608 for the fifth term, or sixth term. So I'm gonna write that right here: fourth term, fifth term, sixth term, because those are the last 3 terms with coefficients. So that is the first problem done. Now we're going to move on to our second content example. And for this one, we're given a table, and this is the probability of a kid spilling a drink 0 times. This is the probability of a kid spilling a drink 1 time in a day. Probability of a kid spilling 2 drinks in a day. Probability of a kid spilling 3 drinks in a day. Probability of a kid spilling 4 drinks in a day. And if 6 days are chosen at random, find the probability that a single kid will spill 2 drinks on exactly 3 days. And so for this one, we're going to use, let me grab my formula booklet. We're going to use the binomial distribution formula, which looks like this. N choose R times P to the power of R times 1 minus P to the power of N minus R. And so to find so first we have to define what N, R, and P is. And so since it's asking us what's the probability that they'll spill 2 drinks, all we have to do is look at where the 2 is. And so the probability of a kid spilling 2 drinks is 0.15, and it's asking us out of a total amount of days, which is 6. So that means N is equal to 6, because that's the total amount of days, and it's asking for a specific amount of the total days, which is 3. So that means R is equal to 3. So now that we have all of our variables defined, we can just plug that in and find our answer. So all we have to do is do 6, choose 3, times 1 or 0.15 to the power of 3 times 1 minus 0.15 to the power of 6 minus 3. And so all we have to do is type that into our calculator. Let me make it so that you can see the calculator better. Okay, please don't fall. Okay. So then we do math, NCR, put 6 over here, 3 over here. That gets you 20. 20 times 1.5 to the power of 3 gets you 0.0675. Do that times 1.5, or 1 minus 0.15 is 0.85 to the power of 3. 6 minus 3 is 3. So, and then that should get you your answer of, your answer is 0.0414 or 5. Go to 3 sig figs. So that's a 5. Here, I'll write it right here. 4, 1, 5. Okay. So the probability of 6 days chosen at random, and find the probability a single kid spills 2 drinks on exactly 3 days is 0.0415. So that is the content example number 2. And so now that we are done with the examples, here are the questions that you need to answer based on the lesson that I just taught. So the first question is, find the coefficient for the third and fifth term in x plus 4 to the power of 8. Here, I'll put that closer to the camera so you can see that. So find the coefficient for the third and fifth term in x plus 4 to the power of 8 expanded. And then the second one, there's your table of the probabilities of those numbers happening. And the probability of a burger being overcooked on a single day is these. And then so 8 days are chosen at random. Find the probability of no burgers, or that no burgers are overcooked on exactly 5 days. Okay, so pause the video here, and I am going to reveal the answers. So pause the video and answer them. Okay, here, let me take this tape off. Oops. Oops. So the answer to the first problem is 448 and 17,920. Answer to the second problem is 0.21875. So those are the answers to the practice problems. Have a nice day.